Hi everyone, today we will talk about data structures and algorithm. Now, what is a data? In computer, users are required to store a lot of data which can be of different types, like integer. The data can be of type alphabetical, string, your name, hello, or anything. It can be of decimal data type 3.14 and many more. These data types are called as primitive data types. The data can also be a composite data type, which is like a combination of these primitive data types, and these are called as non-primitive slash complex data types. How the data is stored in computer? So in computer understands only bit value, and the bit value can either be a 0 or a 1. Hence the instructions which computer understands are written in zeros and ones, which we call as machine code. It is humanly not easy to understand the machine code and write program uh, in a machine level language. To write a program, we generally use high level languages, and there are many high level languages which are available today. For example, there is Java, there is C++, Python, Ruby, JavaScript, Golang, TypeScript, and many more. So how does high level language is converted to a machine level language? So this is a high level language. Here we have defined a variable num1 and its value is 5. Now this high level language is read by a compiler, and compiler converts the language to a language called as assembly level language. This is how this assembly level language looks like. Now this assembly level language is further read by an assembler, and assembler is the one that converts it to a machine level language in zeros and one, and this is what the computer understands. So this is all about the data and how the data is stored in computers, and how the high level language converts the data to a low level language. Now we'll talk about what is a data structure. Now to store data, the complex data types in computers, there are many different types of data structure which is defined, and to solve these are also helpful in solving the real world problems. So below is the list of few data structures which we'll be talking about, and there are many more data structures which will be we'll talk about, but these are few popular ones: arrays, hash tables, linked list, stacks, queues, trees, priority queue, a very important data structure, disjoint sets, graphs, trie. So these are all data structures, and as of today, any application that you are using on your mobile phone, on your computers, or uh, iPad, or any electronic device, uh, they all use these data structures. For example, your if you are using a Windows machine, the folder structure is kind of tree structure. They use tree. We'll be learning more about these in depth in the further sessions. Now, what is an algorithm? An algorithm is a step-by-step set of instructions designed to solve a problem or a task. For example, this is a problem statement that we have to print all the elements of array which contains the numbers from 1 to n. Now what will be the step-by-step instructions for this array? First is we have to iterate over an array until we reach last element of array starting from first element. This will be like read the current element, print that element, and then move on to the next element, repeat the steps 1 and 2. This will be the step-by-step instructions. There can be different algorithms which serve the same purpose. So to pick a better algorithm, we compute the time complexity of an algorithm, and to do that we use the runtime analysis of an algorithm. And how do we do that? So let's take the previous example only, that we have to like print all the elements of an array. The steps for those problem statement to solve the problem was that we were reading the current element, printing that element, and moving on to the next element. So if we look closely on these three steps will run n times, you know, which is the total number of elements present in the array. So the total runtime of a function is n, O of n. The runtime analysis is computed in the form of n as a function of n, where n is the size of the input, and O, this is called as big O notation. This is a general what you can say as a definition how we write the time complexity of an algorithm in software engineering. There are many other different types of algorithm runtime analysis like O1, log n, n square, k to the power n, and so on. You'll encounter many more when we'll be talking about the algorithm, different type of algorithms, and different type of problem statements. There are few algorithms which are used widely and which are actually popular algorithms as well. For example, recursion, sorting, searching. Oh, searching is repeated. String algorithms, greedy algorithm, divide and conquer, dynamic programming, graph traversals, and many more. Thank you.